Hello and welcome. Wherever you are tonight, wherever you are listening from, may this moment be a gentle pause in your day. Perhaps you are lying in bed, the light dim and the air still. Perhaps you are resting after long hours of thought or work, or perhaps you are drifting slowly into sleep. Wherever you find yourself, I invite you to lean back, to breathe deeply, and to follow me into a story about the hidden fabric of the universe. There is a phenomenon so delicate, so strange that even the greatest minds of science once resisted it. A phenomenon not found in ordinary experience, not glimpsed in the turning of planets or the flow of rivers, but revealed only when humanity peered into the smallest scales of nature. It is called quantum entanglement, and it is one of the strangest connections in all of physics. To understand it, we must return to the birth of quantum mechanics in the early 20th century. It was a time of upheaval in science, when familiar certainties crumbled. The atom, once thought to be indivisible, revealed itself as a world of electrons and nuclei, governed not by classical laws but by probability. Light, once imagined as a continuous wave, showed its particle nature in quanta called photons, and everywhere strange dualities emerged. Waves behaving like particles, particles behaving like waves, certainty dissolving into uncertainty. Amid this strangeness, another mystery rose. When two particles interacted, they did not merely bounce off each other like billiard balls. They became linked, fused in a way that went beyond classical connection. Long after they separated, their properties remained correlated. Measure one, and the other revealed itself instantly, as though they were still one system. This was entanglement. Albert Einstein, though one of the architects of quantum theory, recoiled at the thought. For him, the universe should be orderly, local, with influences travelling no faster than light. But entanglement seemed to suggest otherwise, that distance could be irrelevant, that space itself was not what it appeared. He dismissed it as spooky action at a distance, a sign, he believed, that quantum mechanics was incomplete. But the equations did not waver. Schrödinger, who first gave the phenomenon its name, recognized it as the very essence of the new physics. He saw that when two systems meet, their descriptions intertwine. They cannot be separated into independent states. They remain one, no matter how far they drift. For decades, the question remained unresolved. Was entanglement real, or was it an illusion, concealing hidden variables? Could particles truly be bound across space without a signal between them? The debate stretched through generations, carried by physicists and philosophers alike. Then, in the 1960s, John Bell devised a test. He derived inequalities, mathematical boundaries that any local hidden variable theory must obey. If experiments violated these inequalities, then entanglement would be confirmed as real. The tests came. In the 1970s, 1980s and beyond, physicists around the world performed them, and the results were clear. Entanglement was no illusion. The inequalities were broken, again and again. Nature itself refused to be bound by local realism. The strange connection was real. Today, entanglement is no longer an oddity at the margins of theory. It is a central principle of modern physics. Quantum computers rely on it, weaving entangled qubits into machines capable of solving problems no classical device can touch. Quantum cryptography uses it to create unbreakable codes, secure against all intrusion, and experiments extend it ever farther, between laboratories, between satellites, across continents. Yet, for all its applications, entanglement remains mysterious. It defies ordinary language, defies ordinary thought. It suggests that the world is not made of separate parts at all, but of relationships, correlations, patterns that span across space. The particles are not independent objects, but expressions of a deeper whole. And in that thought lies a quiet wonder, that at the heart of reality, separateness is an illusion. Beneath the surfaces, everything is connected, The story of entanglement is not only one of experiments and equations. It is a story of how we see the universe and how the universe may see itself. Imagine two photons born together in the same quantum process. They fly apart, each in opposite directions, travelling at the speed of light. To ordinary sight, they are now separate. 2 points of light, growing ever more distant. But at the quantum level, they are still one. Their polarizations remain perfectly linked. Measure one as vertical, and the other will be horizontal. Measure one as diagonal, and the other will align instantly to match. This instant connection has been tested across kilometers, across mountain ranges, across orbit itself. No matter the distance, the link endures. No matter the obstacles, the correlation holds. It is not carried by a signal, for no signal could travel faster than light. It is not prearranged, for the outcome is not decided until the moment of measurement. It is simply entanglement. Physicists often describe entanglement as the most profound resource of the quantum world. But more than resource, it is revelation. It reveals that the world cannot be understood as a collection of parts assembled into wholes. The whole comes first. The parts are shadows of its deeper unity. Some have suggested that space itself is built from entanglement, that the geometry of the universe, the shape of space-time, arises from webs of quantum connections. In this view, distance is not fundamental. It is an illusion, a measure of how entangled two systems are. Two objects close in space are simply those that share more entanglement. Two objects far apart are those whose connections are weaker. If this is true, then entanglement is not a curiosity. It is the foundation of reality, the loom upon which the cosmos is woven. And perhaps it is not confined to particles alone. Theoretically, entanglement can extend to larger systems, to molecules, to living cells, perhaps even to the mind itself. Already, research has probed the possibility that biological processes harness entanglement, that photosynthesis, navigation, and perhaps even thought may depend upon it. If so, then entanglement is not distant, not exotic. It is within us, around us, the hidden thread binding life to matter, matter to energy, energy to the cosmos. From Einstein's doubt to Bell's proof, from laboratory photons to satellites in orbit, the story of entanglement is one of ever-deepening wonder. It is the reminder that reality is not what it seems, that beneath the apparent separations lies a unity beyond space, beyond time. The particles whisper it in their correlations, in their perfect dances across distance, that everything is joined, that nothing is alone, that the universe is a tapestry of invisible threads. In the stillness of physics there came a shift, a realization that entanglement is not only about particles and their correlations, but about something more fundamental: information. Information in this context is not simply words on a page or signals carried by wires. It is the measure of possibilities, the description of what can be known about a system. In classical physics, information is straightforward. A particle has a position, a velocity, a set of properties that exist, whether measured or not. Information is the catalogue of these facts. But in quantum physics, the situation is more subtle. Properties do not exist until observed. A particle's spin, its polarization, its location, exist only as probabilities, as superpositions, as potentialities. Measurement does not simply reveal information, it creates it. Entanglement deepens this strangeness. When two particles are entangled, their information is not contained in either alone. It resides in the relationship between them. Individually, each particle may appear uncertain, undefined, but together they form a complete system, their properties locked in perfect correlation. The information is in the connection, not the parts. This is a profound shift. It means that information is not merely about objects, but about relationships. That reality itself may be woven not from things, but from the way things are entangled. From this insight grew the field of quantum information theory. Here, physicists treat entanglement not as a curiosity, but as a resource. Entangled particles become carriers of quantum bits, or qubits, the foundation of quantum computation. Unlike classical bits, which are either 0 or 1, qubits can be both in superposition. And when entangled, their states combine in ways that allow computation across many possibilities at once. In laboratories, scientists cool ions, trap photons, manipulate electrons. They weave them into networks of entangled qubits, coaxing fragile correlations into stability. In these delicate machines, entanglement is not an obstacle, but the very engine of power. Problems that would take classical computers longer than the age of the universe may be solved by quantum computers, their strength flowing directly from entanglement. Beyond computing, entanglement becomes the basis for communication. In quantum cryptography, entangled pairs allow messages to be transmitted with absolute security. Any attempt to eavesdrop disturbs the entanglement, revealing the intrusion. In this way, entanglement guards the flow of information, creating codes that cannot be broken, even by quantum machines themselves. And then there is teleportation, not of bodies or objects, but of states. Using entanglement, the exact quantum state of a particle can be transferred across space, disassembled in one location and reassembled in another, without the particle itself travelling. Already this has been demonstrated in laboratories, across fibres, across free space, even from Earth to orbit. Entanglement thus becomes not only a feature of reality, but a tool, a means of harnessing the deep unity of nature. But its implications reach further still. In theoretical physics, entanglement may hold the key to some of the deepest puzzles of all. Black holes, with their event horizons, swallow information, raising paradoxes about its fate. But entanglement may resolve them, suggesting that information is not lost, but encoded in correlations at the horizon. Space itself, some argue, may emerge from entanglement, its geometry arising from networks of quantum links. In this vision, reality is not made of matter or energy, but of information, and entanglement is the language in which that information is written. It is a quiet revolution. Where once physics sought particles and forces, now it seeks correlations and codes. Where once reality was imagined as objects moving through space, now it is imagined as entangled states unfolding into experience. Entanglement whispers that the world is not a machine, but a message, not a collection of parts, but a web of information. And in that whisper lies a new way of seeing, that to know the universe is not to count its objects, but to trace its connections. Section 4. Entanglement and the nature of time. If entanglement reshapes our understanding of information, it also bends our understanding of time. In classical thought, time is a river, flowing from past to future. Events unfold in sequence, cause leading to effect, moment leading to moment. But entanglement disrupts this picture. Consider two particles entangled and then separated. When one is measured, the other responds instantly, regardless of distance. To classical thought, this seems to suggest a violation of time's order, an effect without a signal, a correlation without a cause. But perhaps the truth is deeper. Entanglement reveals that time itself is not what it seems. In some interpretations of quantum mechanics, entanglement does not involve influences travelling faster than light. Instead, it suggests that the particles are not truly separate in the first place. Their connection transcends space and time, existing in a domain where these categories do not apply. The correlations appear instant because, at the fundamental level, there is no distance to cross, no time to wait. In this view, time emerges only at larger scales, from the decoherence of entangled systems into classical states. The arrow of time, with its forward flow, may itself arise from entanglement, from the spreading of correlations throughout the universe. Experiments now probe this idea. In laboratories, entangled particles are manipulated to test the role of time in their behavior. In some scenarios, the order of events seems indeterminate, as though cause and effect blur, as though time is not a fixed stage, but a flexible outcome. Some physicists suggest that entanglement is the root of temporal order itself, that the reason events seem to flow forward, the reason memory is of the past and not the future, is because entanglement spreads irreversibly, weaving systems together in ways that cannot be undone. The arrow of time may thus be the arrow of entanglement. Beyond physics, this thought is dizzying. It suggests that time, which feels so fundamental, may be secondary, derivative. That beneath the flow of moments lies a timeless web, a vast entangled state from which time emerges as appearance. Black holes again provide a stage for this mystery. At their horizons, entanglement seems to stretch across space and time, binding the interior to the exterior, the past to the future. Some theories propose that the singularity at a black hole's heart is not a place in space, but a collapse of time itself, resolved not by classical mechanics, but by the spread of entanglement. And in cosmology, entanglement may underlie the birth of the universe itself. The early cosmos, dense and hot, was a sea of correlations, particles entangled across the whole. As it expanded, those correlations spread, shaping the structure of galaxies, the distribution of matter, the very flow of time as you know it. In this vision, your own sense of time, the ticking of clocks, the memory of moments, the anticipation of future, is a ripple of entanglement, a shadow of correlations spreading through reality. Entanglement does not merely connect particles, it may connect past and future, present and possibility. It may reveal that time is not a river, but a tapestry, woven from threads that do not run in sequence but all at once. And so, entanglement reshapes not only what space is, not only what matter is, but what time itself is. It invites us to see the world not as a sequence of isolated events, but as a unity, a whole, timeless at its core, yet unfolding into the flow we experience. In this, entanglement is not only a scientific discovery, but a philosophical mirror. It shows that reality may be more than sequence, more than cause and effect. It may be a timeless web, a vast harmony, in which time itself is an emergent melody. Inside a quiet laboratory, the hum of machines fills the air. Lasers beam through crystals. Detectors click softly, and screens glow with faint signals from the quantum world. This is where entanglement is not only theory, not only mathematics, but reality made visible. To create entanglement, physicists must work with care. At the quantum scale, the slightest disturbance can destroy correlations, collapsing superpositions into classical certainty. Entangled states are delicate, fragile, like threads of spider silk stretched across vast space. They must be generated, guided, and preserved with precision. One of the simplest methods uses light. A laser beam passes through a crystal, and in the process called spontaneous parametric down conversion, a single photon splits into two. These twin photons share energy, momentum, polarization. They are entangled, born from one process, one event, their fates linked forever. From this birth, they are sent in different directions, sometimes through fibers that snake across the laboratory, sometimes through open air. Sensitive detectors wait to measure them, recording their polarizations, their correlations. When the data is gathered, the pattern emerges. Perfect correlations across space, confirming the entanglement that theory predicts. These experiments must contend with decoherence, the enemy of entanglement. Decoherence occurs when entangled systems interact with their environment. A stray vibration, a collision with an air molecule, a fluctuation in temperature, all can disrupt the delicate superposition, collapsing the state into classical outcomes. To protect against this, experiments are often cooled to near absolute zero, shielded from noise, isolated from disturbance. The precision is astonishing. A laboratory may spend years perfecting an apparatus, adjusting alignments by fractions of a degree, calibrating detectors to catch faint signals. For the human eye, the photons are invisible. For the mind, the phenomenon is intangible. But for the instruments, the reality is undeniable. Entanglement is there, woven into the clicks of detectors, the bursts of light, the data that reveal hidden unity. Beyond photons, entanglement can be created with atoms, ions, superconducting circuits. In ion traps, charged atoms are held in electromagnetic fields, cooled and manipulated with lasers until their internal states become entangled. In superconducting systems, tiny currents flow in circuits, cooled to near zero, entangled qubits forming the building blocks of quantum processors. Each platform offers its own challenges, its own strengths, but the goal is the same: to capture entanglement, to sustain it, to use it. These laboratories are more than rooms of equipment. They are sanctuaries of precision, spaces where human ingenuity meets the strangeness of the quantum. Within their walls, entanglement is no longer abstract. It is tangible, measurable, usable. And slowly, steadily, the experiments grow. What began as pairs of photons across a table has expanded into networks spanning cities, into satellites that send entangled particles from orbit to Earth. Entanglement has travelled across mountains, across seas, across the airless space above. Each experiment confirms the same truth. The connection holds. Across distance, across barriers, across all attempts to divide them, entangled particles remain one. In these laboratories, scientists glimpse a deeper order. They see that the universe is not made of isolated parts, but of fragile, invisible threads. They watch as those threads stretch, bend, endure. And they know that in this fragility lies the foundation of a new age of technology, a new way of understanding reality itself. Entanglement, once dismissed as spooky, now glows in the detectors, whispers in the data, shines in the experiments that capture its elusive beauty. From the quiet of laboratories, entanglement has been carried outward into the world beyond. In 2017, a satellite named Mikius orbited high above the Earth, carrying instruments designed to create and send entangled photons. From space, it beamed them to 2 ground stations separated by more than 1,000 kilometers. The photons, though split by such distance, remained entangled, their correlations intact. This was more than experiment. It was proof that entanglement could survive not only across laboratories, but across the vast scales of Earth itself. Other projects followed. Fibers spanning cities carried entangled photons, linking laboratories, universities, and research centres. Quantum networks, fragile but growing, began to take shape, weaving connections across continents. The goal is ambitious: to build a quantum internet, an entangled web stretching across the globe. In such a network, information would be transmitted not by ordinary signals, but by entangled states. Security would be absolute, protected by the laws of physics. Communication would be instantaneous in principle, though bound by the need for classical channels to complement the quantum link. Step by step, the vision grows. Each successful experiment extends the reach of entanglement, proving that it is not confined to small scales, not too delicate for the world. It endures across distance, across obstacles, across the challenges of engineering. And as it stretches outward, the philosophical weight grows too. If entanglement can span continents, if it can endure from orbit to Earth, what does that say of the universe? Perhaps entanglement is not rare, not exotic. Perhaps it is everywhere, linking all things, visible only when measured, but present nonetheless. In the satellites and fibers, in the clicks of detectors across mountains and cities, entanglement becomes not just theory, but infrastructure. The strange connection is woven into technology, into the daily fabric of human communication. But beyond the technology lies wonder. To see photons, born together in a crystal, separated by the curve of the earth, yet still bound, still one, is to glimpse something profound. That distance is not what it seems, that separation is illusion. In this sense, every experiment is also a meditation. Each correlation recorded across kilometers is a reminder that the universe does not let go of its unity, that from the smallest scales to the largest, from laboratory tables to orbiting satellites, the hidden thread endures. The Earth itself becomes a stage for this revelation. Mountains, oceans, atmosphere, space, none can break the connection. Entanglement whispers across them all, unbroken, serene, strange. And so, entanglement is no longer confined to the delicate apparatus of physics. It is stretched across the earth, carried by human ingenuity, confirmed by patient measurement. It is no longer only spooky action, no longer only paradox. It is reality itself, woven across continents, shining in the light of distant photons. There is a word that belongs more to myth and science fiction than to physics: teleportation. The instant transfer of objects across space, the vanishing from one place and the reappearance in another. For centuries it lived in imagination, in stories of sorcery and speculation. Yet within the realm of quantum physics, teleportation has taken on a different, very real meaning. Not of matter, but of information. And at its heart lies entanglement. The process begins with an entangled pair of particles. Let us call them A and B. Particle A is kept by a sender, and particle B is carried away to a distant receiver. Their link, invisible yet undeniable, stretches across space. Now imagine that the sender has another particle, C, whose exact quantum state they wish to transfer to the receiver. The challenge is that quantum states cannot be copied. They are delicate, unique, destroyed by measurement. To move state C across space, something more subtle must occur. Here is where entanglement reveals its power. The sender entangles particle C with particle A. By performing a joint measurement on these two, the information about C's state is not revealed, but transformed. The result of this measurement is then sent by ordinary classical communication to the receiver. With this information, the receiver manipulates particle B, the entangled twin, and astonishingly, particle B takes on the exact state that particle C once held. The state has been teleported, not copied, not transmitted in the usual sense, but transferred perfectly across distance. Particle C's state has vanished at the sender and reappeared at the receiver, carried by the invisible thread of entanglement. This is quantum teleportation. The first demonstrations occurred in the 1990s, with photons across short distances. Since then, teleportation has been performed with increasing sophistication. Photons across kilometers, trapped ions in laboratories, even from Earth to orbit via satellites. Each experiment confirms the same truth. Entanglement can carry quantum states across space, intact, precise, instantaneous in principle, though always accompanied by the necessity of classical signals. Teleportation does not move matter itself. It does not dematerialize and reassemble objects as in science fiction. What it transfers is the essence of the particle, its quantum state, its unique pattern of probabilities. The matter remains. The information leaps, and yet in a universe where information and state are fundamental, this is no small thing. To teleport a state is to move identity, to transfer the very description of being. The implications are profound. Quantum teleportation may become the backbone of future communication, linking nodes in quantum networks, ensuring that states are transmitted securely and perfectly. It may underlie quantum computing allowing qubits to be transferred across processors, across distances, across the world. But beyond the practical, teleportation is also symbolic. It reveals that entanglement is not passive, not merely a curiosity. It is an active channel, a highway across the fabric of space, carrying information in ways that defy classical thought. It shows that separation is not absolute, that unity can be used, harnessed, made to serve the transfer of identity. In teleportation, entanglement becomes more than connection. It becomes motion, not of particles, but of essence. The invisible thread does not simply bind, it carries. And in this, teleportation becomes more than technology. It becomes metaphor. For perhaps in some deep sense, all transfer is like this. Identity is not carried by matter alone, not bound to location, but woven in patterns, in correlations, in states that can be passed along invisible threads. To witness teleportation is to glimpse a universe where movement is not only through space but through connection, where distance dissolves into relationship, where the strange unity of entanglement reveals its most astonishing gift, the power to carry being itself across the void. From teleportation grows a vision, the vision of a quantum network, an internet woven not from wires and radio signals, but from entanglement itself. In today's world, information flows through classical channels. It moves as electrical pulses in circuits, as light in fibers, as waves in the air. These signals can be copied, intercepted, decoded. Security depends on mathematics, on algorithms that may one day be broken by quantum machines. But in a quantum network, the foundation would be entanglement. Pairs of particles distributed across distances, linking nodes in invisible unity. Messages carried not as copies, but as entangled states, unbreakable by any intrusion. Teleportation used to move qubits across the network, maintaining coherence, preserving information in ways no classical system can. The architecture is being imagined. Satellites distribute entangled photons to ground stations. Quantum repeaters, using chains of entangled pairs, extend the reach across continents. Laboratories across the world are building prototypes, small networks linking a handful of nodes, testing teleportation, encryption, synchronization. The promise is staggering. A quantum internet could allow distributed quantum computers to work as one, solving problems beyond the reach of any single machine. It could create communication channels immune to interception, secure not by secrecy, but by the very laws of physics. It could synchronize clocks with unprecedented precision, enabling new sciences, new technologies. But more than applications, the quantum network represents a philosophical leap. It is the recognition that information does not belong only to objects, but to connections. That the future of communication is not transmission through separation, but expression of unity. In such a network, distance becomes less relevant. What matters is entanglement, the degree to which nodes share correlations. A network spanning Earth would mirror, in miniature, the unity of the cosmos itself, where all things are linked by invisible threads. Already, experiments hint at what is possible. Entanglement shared between cities, teleportation across kilometers of fiber, satellites distributing entangled pairs. The steps are small, fragile, experimental. Yet each is a step toward the dream. A web not of matter but of connection, not of signals but of states, not of distance but of unity. And as this dream grows, it reshapes how we see the world. The classical internet connected objects, computers, phones, machines. The quantum network will connect states, identities, essences. It will not merely transmit data, it will weave entanglement into infrastructure, into daily life. To imagine it is to imagine a civilization built not on separation, but on unity. A society where information is not vulnerable, not divided, but secure, coherent, whole. A world where the strange connection of entanglement becomes ordinary, woven into the rhythm of communication, commerce, science, and thought. And perhaps beyond technology, the quantum network is a symbol of what humanity seeks: connection that endures across distance, unity that survives division, a web of belonging that reflects the deeper truth of the universe. For entanglement is not only physics, it is metaphor, it is reminder. It is the quiet voice of reality whispering that nothing is truly separate, that unity is deeper than distance, that beneath the appearance of isolation lies a fabric of connection waiting to be seen. The quantum network is still a dream, but it is a dream that grows step by step, experiment by experiment. And with each success, with each entangled photon sent across the Earth, the dream becomes more real. Perhaps one day you will live in a world where every message, every connection, every moment of communication is carried by entanglement. And when that day comes, the strange connection of quantum particles will no longer be spooky, no longer be mysterious. It will be ordinary. And in its ordinariness, it will remind us of something profound, that we were always connected, that the threads were always there, waiting only to be woven into our lives. To understand entanglement, it is tempting to think in terms of pairs: two photons, two electrons, two particles bound by invisible correlation. But this view, though useful, hides a deeper truth. Entanglement is not about pairs, it is about wholeness. In quantum mechanics, when two systems interact, they lose their independence. Their states merge into one. And when more systems are added, 3, 10, 1,000, the same principle applies. The entanglement does not stop at two. It expands, weaving systems together into larger wholes. This leads to a startling possibility, that the universe itself, born from a single origin, is entangled as a whole. That every particle, every atom, every star, every galaxy is not separate, but woven into a single state. Such a thought is not fantasy. In the early universe, when matter was dense and hot, particles were in constant interaction, colliding, exchanging, entangling. As the cosmos expanded, these correlations spread outward, frozen into the structure of space-time, imprinted into the background radiation. Even today, remnants of those primordial entanglements may persist, linking distant parts of the universe in ways subtle but real. If so, then the unity revealed in the laboratory is not confined to experiments. It is a glimpse of the deeper truth, that separateness is appearance, that wholeness is reality. Physicists like David Bohm spoke of this wholeness. To him, quantum theory suggested that the world is not built of independent parts, but of an undivided whole. What appears as separate is merely the unfolded aspect of a deeper order, what he called the implicate order. In this view, particles are not things in themselves, but expressions of a deeper unity. Entanglement fits perfectly into this vision. It shows that the universe does not allow isolation, that no system can be fully described without its context, that the parts are shadows and the whole is primary. This challenges not only physics, but philosophy. For centuries, Western thought has emphasized separation, the division of subject and object, of self and other, of matter and mind. But entanglement suggests another path, one of unity, connection, holism. It suggests that reality cannot be understood by breaking it down, but only by seeing it as a whole. Even science itself is touched by this, for the method of science often divides, isolates, analyzes. It seeks the parts, the components, the mechanisms. But entanglement reveals that the parts may not have independent existence, that the act of division hides the true nature, which is wholeness. In this sense, entanglement is not just a feature of physics. It is a lesson, a mirror, a teaching. It shows that unity is deeper than division, that the world is not a machine of separate parts, but a web of inseparable correlations. The implications ripple outward. In biology, in ecology, in psychology, the lesson of wholeness applies. A forest is not merely trees, it is relationships, soil, air, water, light, an entangled system of life. A mind is not merely neurons, it is patterns, connections, correlations that span the whole. And perhaps, Entanglement whispers, even consciousness itself is not an isolated spark, but a web of correlations, a unity beyond the brain, beyond the self, beyond the individual. Whether or not this is true in a strict scientific sense, the metaphor is powerful. Entanglement shows that unity is not abstraction, but reality. That wholeness is not ideal, but fundamental. That beyond the divisions of thought and perception, the world is one. And so, when physicists watch entangled photons dance across detectors, they are not only measuring particles, they are glimpsing wholeness. They are seeing, in data and graphs, the reflection of a truth as old as existence, that nothing is separate, that all is one. The question arises, if entanglement reveals unity in matter, might it also play a role in mind? The brain is a vast network of neurons, billions of cells firing in intricate patterns. Traditionally, neuroscience explains thought and consciousness as emerging from these patterns, from electrical and chemical signals exchanged across synapses. It is a classical picture, mechanistic, local, but some have suggested that this picture is incomplete. That consciousness, with its unity of experience, may require something more. That entanglement may provide a clue. In quantum biology, researchers explore the possibility that living systems harness quantum effects. Evidence suggests that photosynthesis, the process by which plants capture light, relies on quantum coherence, that birds navigate by quantum entanglement in their eyes, sensing Earth's magnetic field, that enzymes catalyze reactions by tunneling quantum states. If biology can use quantum effects, why not the brain? Some theories propose that entanglement may link neurons or subneuronal structures in ways that classical models cannot explain. That consciousness may arise not from independent firings, but from entangled correlations, weaving the brain into a unified whole. This remains speculative, unproven, controversial. Experiments are difficult, the brain noisy, and warm compared to the fragile isolation of quantum laboratories. And yet the idea persists, whispering of connections deeper than chemistry, of unity beyond synapses. Even if entanglement does not literally underlie consciousness, the metaphor remains. Consciousness is unity, the binding of sensations, thoughts, memories into a single field of awareness. Entanglement, too, is unity, the binding of particles into a single state. The resonance is striking, the parallel profound. Philosophers have long asked, how can the many become one? How do countless neurons give rise to the singularity of experience? Entanglement offers an image, that the whole comes first, that unity is fundamental, that parts are only aspects of a deeper whole. This vision reaches beyond the brain. If entanglement binds particles, and if consciousness arises from matter, then perhaps consciousness too is part of the great web. Perhaps mind is not confined to skulls, not bound to individuals, but part of the unity of the cosmos. Such thoughts are speculative, philosophical, unproven, but they flow naturally from the lesson of entanglement. That separation is illusion, that unity is deeper. Even if entanglement plays no literal role in mind, its lesson shapes how we see ourselves. It reminds us that we are not isolated egos, but parts of a whole. That consciousness, like matter, may be less about separation and more about connection. And perhaps when we feel moments of deep unity with others, with nature, with the cosmos, we are, in some way, resonating with the deeper truth of entanglement. In this sense, entanglement becomes more than physics. It becomes philosophy. It becomes poetry. It becomes a way of seeing the world and ourselves, not as separate islands, but as threads in a single tapestry woven by invisible correlations, bound in unity beyond space and time. There is a question older than science itself. What is space? To the ancients, space was the backdrop against which matter moved, the emptiness that held the stars, the void in which planets circled. To Newton, it was absolute, a stage that existed independently of all it contained. To Einstein, it was flexible, curved by gravity, shaped by mass and energy. But in the quantum world, another possibility emerges, that space is not fundamental at all, that it is born from entanglement. This idea, radical yet increasingly influential, arises from attempts to reconcile quantum mechanics with general relativity. Gravity, as Einstein described it, is the curvature of space-time. But quantum mechanics does not speak of curvature. It speaks of states, probabilities, correlations. To bring the two together requires new ways of thinking. In recent years, physicists have discovered a remarkable link. The geometry of space-time seems to be tied to the entanglement of quantum states. In particular, in models of the universe based on holography, where a higher dimensional space is described by a lower dimensional quantum system, entanglement directly determines the shape of space. Consider the Ryu-Takayanagi formula, a cornerstone of this field. It states that the entropy of entanglement between two regions of a quantum system corresponds to the area of a surface in the higher dimensional space. In other words, the geometry of space, its curves, its boundaries, its very shape, is encoded in entanglement. This is more than mathematics. It suggests that space itself emerges from entanglement, that the reason objects appear near or far, the reason distances exist, is because of how strongly systems are entangled. Two regions with high entanglement appear close in space, those with less appear distant. Space is not a container. It is a map of correlations. If true, this is a revolution. It means that what we call the universe is not built upon space, but upon entanglement. That the stage is not fundamental, but emergent. That beneath the geometry of galaxies and the curvature of black holes lies a web of quantum connections, weaving space-time itself. Black holes provide the most striking example. For decades, they posed a paradox. What happens to information that falls inside? Classical relativity suggested it was lost forever. Quantum mechanics insisted it must be preserved. The resolution, many now believe, lies in entanglement. Information is not lost, it is encoded in correlations across the event horizon, woven into the entanglement between the inside and the outside. In fact, some physicists propose that the very interior of a black hole is constructed from entanglement, that the smooth geometry of space-time within arises from the connections across its boundary. Without entanglement, space would tear apart, collapsing into nothing. From black holes to the universe as a whole, the lesson is the same. Entanglement may not be a feature within space-time. It may be the fabric from which space-time is woven. This vision is breathtaking. It dissolves the separation between physics of the very small and physics of the very large. Quantum mechanics and general relativity, long thought irreconcilable, may find unity in entanglement. The cosmos itself becomes not a stage but a tapestry, woven not of threads of matter but of correlations. And within this tapestry, we are not observers standing apart, but participants, entangled with the whole. To see entanglement as the fabric of space is to glimpse a universe where unity is deeper than geometry, where distance is appearance, where the true reality is connection. It is to realize that when you look across the night sky, across the span of galaxies and stars, you are not seeing separation, but the unfolding of entanglement into the illusion of space. And so entanglement does not only link particles, it may link the universe itself, weaving space from unity, creating the stage upon which all existence unfolds. If entanglement weaves space, what does it say about the beginning of time, about the birth of the universe itself? The story of the cosmos begins with the Big Bang, a moment when space expanded from a state of unimaginable density and heat. In the earliest instance, particles did not exist as separate entities. They were fields, fluctuations, energies intertwined in chaos. In that chaos, entanglement was everywhere. Quantum fluctuations in the early universe, magnified by inflation, gave rise to the structure we see today. The galaxies, the stars, the cosmic web. These fluctuations were not independent. They were entangled, correlations spread across vast distances, imprinted in the cosmic microwave background radiation. Even now, billions of years later, those correlations remain, a faint whisper of the universe's quantum birth. Physicists study these imprints, mapping the slight variations in temperature across the sky. In those variations lies evidence of entanglement, traces of the unity that shape the cosmos. The structure of the universe, the clustering of galaxies, the great filaments that span across space may all be consequences of quantum entanglement at the dawn of time. Some theories go further. They suggest that before the Big Bang, the universe existed not in space and time, but in a pure entangled state. That the Big Bang was not the creation of matter, but the unfolding of entanglement into space and time. That what we call the beginning was the moment when unity blossomed into multiplicity, when wholeness unfolded into the appearance of parts. In this vision, the universe did not arise from nothing. It arose from entanglement. Space and time are not fundamental. They are emergent, born from correlations, spreading outward, weaving the cosmos into being. Even the arrow of time, the flow from past to future, may be explained this way. As entanglement spreads, correlations increase, systems become more linked, more unified. This irreversible growth gives rise to the direction of time. The past is the state of less entanglement. The future is the state of more. The universe, then, is not a machine of parts moving in emptiness. It is a web of correlations, expanding, unfolding, entangling more deeply as it evolves. Its birth was not the creation of objects in space, but the emergence of space itself from the unity of entanglement. To reflect on this is to feel awe. The galaxies overhead, the stars that shine, the earth beneath your feet, all are expressions of a unity older than time, a wholeness that has never been broken. The Big Bang was not the separation of things, but the flowering of connection. And perhaps entanglement whispers, the universe has never ceased to be whole. The separations we see, between star and star, between self and other, are appearances, surface ripples of a deeper unity. Beneath them all, the entanglement remains, timeless, unbroken, the true foundation of reality. In this sense, the birth of the universe is not only a physical event, but a reminder. It reminds us that creation is not division, but connection. That to exist is to be entangled. That the cosmos, from its first moment to its present, is one. And so, entanglement carries us back to the beginning. It shows that the universe did not emerge into space and time, but that space and time emerged from entanglement. That creation was not the separation of parts, but the unfolding of wholeness. And in that wholeness, we find not only the story of the cosmos, but the story of ourselves. Black holes have always been symbols of mystery. They are places where gravity is so strong that nothing, not even light, can escape. They are regions where space curves inward until it seems to end, where time itself halts at the singularity. But for physicists, black holes are not only astronomical marvels, they are paradoxes that challenge the very foundation of physics. At the heart of the paradox lies information. According to general relativity, when something falls into a black hole, it is lost forever. The black hole grows, its horizon expands, but the details of what fell inside, the structure of atoms, the arrangement of particles, the information that defines the object, is gone. But according to quantum mechanics, this cannot be. Information, in the strict sense, cannot be destroyed. The state of a system may evolve, may transform, but it must always be preserved. The universe, at its deepest level, does not allow information loss. This clash between relativity and quantum mechanics is the black hole information paradox, and many now believe the resolution lies in entanglement. Imagine a black hole forming as a star collapses. The matter falling inward becomes part of the singularity, hidden beyond the horizon. But as the black hole radiates, through the slow leak known as Hawking radiation, pairs of particles are created at the edge of the horizon. One particle escapes, the other falls in. To conserve quantum information, these pairs must be entangled with each other. As the process continues, more and more entangled pairs are emitted. But here is the paradox. If the interior and the radiation are entangled, then when the black hole evaporates completely, the interior is gone. What happens to the entanglement? If it is lost, information is destroyed. If it is preserved, where is it stored? This question has driven decades of research, and slowly a picture has emerged. Entanglement may not only connect particles across the horizon, it may actually create the horizon. The smooth geometry of space-time at the edge of the black hole may exist only because of entanglement between inside and outside. This leads to a bold idea that space-time itself is woven from entanglement, that without entanglement, space would rip apart, collapsing into fragments. In this view, the black hole paradox is resolved not by hiding information, but by rethinking what space is. The information is not lost, it is encoded in entanglement across the horizon. Some have gone further. They propose that the interior of a black hole is connected to the outside by a wormhole, a bridge created by entanglement. This idea, called EREPR, suggests that Einstein-Rosen bridges, wormholes, and Einstein-Podolsky-Rosen pairs, entanglement, are two faces of the same phenomenon. That entanglement is geometry, that a wormhole is simply what entanglement looks like when drawn in space. If true, then black holes are not prisons of loss, but laboratories of connection. They show us that the universe is not built of separate parts, but of entanglement weaving horizons, shaping space, preserving information in hidden correlations. In this sense, black holes are not ends but mirrors. They reflect the deepest lesson of entanglement. That wholeness is fundamental, that division is appearance, that information is never lost because the universe itself is an entangled whole. And perhaps when the last black hole evaporates, when the universe reaches its distant future, what remains will not be ashes of information, but the wholeness of entanglement, preserved eternal, the true foundation of reality. From black holes arises another idea, even stranger, that the universe itself is a hologram. The concept of holography is familiar in technology. A hologram is a two-dimensional surface that encodes a three-dimensional image. Light scattered from the surface, when viewed, appears as depth, as volume, as space. Physicists now suggest that reality may work the same way, that the three-dimensional world we experience may be encoded on a two-dimensional boundary, that the universe is holographic. The roots of this idea lie again in black holes. Jacob Bekenstein and Stephen Hawking discovered that the entropy of a black hole, the measure of its information, is proportional not to its volume, but to the area of its horizon. This was shocking. Normally we expect information to scale with volume, with how much space is available, but black holes showed otherwise. The information content was on the surface, not the inside. This led to the holographic principle, that the fundamental description of reality may reside not in the space we experience, but on its boundary, that our universe may be a projection, like a hologram, emerging from information encoded on a cosmic horizon. And entanglement is central to this picture. In holographic models, the geometry of space arises directly from the entanglement structure of the boundary. The Ryu-Takai-Yanagi formula shows that entanglement entropy corresponds to areas in the bulk. The shape of space, the curves of geometry, the presence of horizons all emerge from patterns of entanglement. This is more than mathematics. It is a vision of reality as information, as correlations, as entangled codes. It suggests that what we call space-time is not fundamental, but emergent. That the universe is not a stage but a story, projected from a deeper layer of entanglement. In this view, black holes are not singular mysteries, but windows into truth. They show us that information is not hidden inside, but stored on horizons. They reveal that entanglement does not live within space. Space lives within entanglement. The holographic principle extends beyond black holes. It suggests that the entire cosmos, from galaxies to particles, may be a hologram. That what we see as depth is correlation. That what we feel as space is entanglement. Philosophically, this is profound. It means that separation is illusion. That reality is not made of objects in space, but of information encoded on a boundary. It means that our lives, our thoughts, our world may be projections of deeper patterns of entanglement. And yet if this is true, it does not diminish reality, it deepens it. A hologram is not false, it is real in its own way, an expression of information. The universe, as hologram, is no less real. It is simply the unfolding of entanglement into experience. In this vision, entanglement is the hidden script of the cosmos. It writes the geometry of space, the flow of time, the structure of matter. It encodes the story of reality, projecting it as the universe we inhabit. And perhaps when we look at the stars, when we feel the depth of space, we are seeing not distance, but entanglement, not emptiness, but information, not separation, but unity. The holographic universe is a bold idea, still tested, still debated. But whether or not it is true in detail, its spirit captures the essence of entanglement. That reality is not division, but connection. That what seems solid and separate is the unfolding of unity. That beneath the surface of experience lies a deeper layer, a boundary of information, an entangled code from which all arises. And so, entanglement does not only connect particles, does not only weave space, it may be the very canvas upon which the universe is drawn, the holographic medium through which reality itself shines. Quantum mechanics is filled with paradoxes. Among them, none is more famous than the question of measurement. When a quantum system exists in a superposition, what happens when we look at it? Does the wave function collapse, producing a single outcome, or does something stranger occur? One interpretation, bold and radical, is the many worlds interpretation. Proposed by Hugh Everett in the 1950s, it suggests that wave functions never collapse. Instead, every possible outcome happens. When a particle could be spin up or spin down, the universe splits. In one branch it is up, in another it is down. Both are real, both exist, both continue, but we experience only one. In this vision, the universe is not a single unfolding story, but a vast branching tree of possibilities, splitting at every quantum event into countless parallel worlds. Every choice, every chance, every particle's state creates new branches. The multiverse grows endlessly, a forest of realities. Where does entanglement fit in? Entanglement is the glue that binds these branches together. When two particles are entangled, their fates are correlated across worlds. In one branch, if one is spin up, the other is spin down. In another branch, the roles reverse. The correlations span across the branching tree, weaving consistency into the multiverse. Without entanglement, the many worlds would be chaos, fragments with no coherence. With entanglement, the branches align, the outcomes balance, the probabilities match. Entanglement ensures that when universes split, they split in harmony. Some physicists speculate further. Perhaps entanglement not only organizes worlds within the multiverse, but connects them. Perhaps when particles are entangled, the correlations are not merely within one branch, but across many, weaving the multiverse into a single whole. If this is true, then entanglement is not just a property of quantum systems. It is the fabric of the multiverse. It is what keeps the branching worlds from drifting apart, what ensures coherence, what binds the infinite possibilities into a single structure. Philosophically, the implications are staggering. If every possible outcome happens, then every version of you exists. The one who chose left, the one who chose right, the one who spoke, the one who remained silent. All are real, all are entangled in the great web of the multiverse. And yet, though the branches multiply, you feel only one. Why? Perhaps because consciousness, too, is entangled, confined to a single consistent branch. Or perhaps because awareness does not travel across worlds, but is woven within one. Still, the existence of others remains, invisible but implied, part of the wholeness that entanglement preserves. In this sense, entanglement is more than physics. It is existential. It suggests that the universe is larger than perception, that reality is not singular, but branching, that wholeness spans not only space and time, but possibility itself. To imagine entanglement in many worlds is to imagine a cosmos where nothing is lost, where every outcome is real, where wholeness extends beyond what can be seen. It is to feel awe at the immensity of reality, to glimpse the possibility that your life is but one path among countless, all entangled, all unfolding in harmony. And perhaps in quiet moments, you may wonder, what is entanglement linking you to in those other worlds? What other versions of you walk those parallel paths, bound invisibly by the same correlations that bind particles? What unity exists across the multiverse, unseen but real? Entanglement whispers that wholeness is deeper than choice, deeper than chance, deeper even than worlds. That the multiverse is not chaos, but harmony, woven together by invisible threads of connection. If the many worlds interpretation imagines branching within a single quantum universe, other theories go further, proposing entire universes beyond our own, bubble universes, pocket worlds, parallel realities with different laws, different constants, different histories. This is the multiverse in its grandest sense, not just many branches of one-wave function, but countless universes, vast and varied, beyond the horizon of our own. In such a vision, a question arises: are these universes separate, or are they connected? If connected, how? And here, once again, entanglement enters. Some physicists propose that entanglement may not stop at the boundaries of our universe, that correlations could exist between universes, linking them in ways we cannot see, that what appears as separate realms may be woven into a larger whole. Hints come from cosmology. Some anomalies in the cosmic microwave background, the afterglow of the Big Bang, have been interpreted as possible signs of interaction with other universes. If so, those interactions might be forms of entanglement, faint traces of correlations across cosmic boundaries. Others turn to theory. In string theory and holography, universes can be seen as brains, membranes floating in higher dimensions. If two brains are entangled, their dynamics may be correlated, their histories linked. In this view, entanglement is not confined to particles, but extends to universes themselves, weaving the multiverse into one structure. Philosophically, this resonates with the deepest lesson of entanglement, that nothing is truly separate. If entanglement weaves space, if it binds particles, if it unites branches of possibility, why should it stop at the edge of one universe? Perhaps even universes are not islands, but threads in a greater tapestry, bound by invisible correlations across the multiverse. If true, the implications are profound. It would mean that our universe is not isolated, not alone, but part of an entangled whole. That the constants of physics, the flow of time, the fabric of space are shaped not only by local laws, but by correlations with other realms. That existence itself is larger than what we see, larger than our cosmos, larger than the horizon of observation. Even if such entanglement cannot be measured directly, it serves as a metaphor. It reminds us that separateness is illusion, that unity is deeper, that the multiverse, however vast, may itself be one. And perhaps in some ultimate sense, the multiverse is not a collection of disconnected worlds, but a single, entangled state, a cosmic wave function unfolding in infinite variety, all bound, all connected, all one. This vision is dizzying. It dissolves the boundaries of reality, stretches imagination beyond comprehension, invites awe at the immensity of being. And at its heart is entanglement, the same phenomenon glimpsed in laboratories, whispered in photons, measured in detectors. The same thread that binds particles may bind universes. The same unity that shapes atoms may shape the multiverse. To think of this is to feel wonder. The experiments on Earth, the fragile photons splitting crystals, the entangled ions in traps, these may be small windows into a truth so vast that it encompasses all existence. They may be glimpses of a unity that does not stop at worlds but stretches across realities, binding them in wholeness. And so, entanglement carries us beyond our universe. It whispers that reality is not one, but many, not separate, but whole. That the multiverse, however vast, is a single tapestry, woven of invisible threads of correlation. And in this tapestry, you are not separate. You are part of the whole, entangled not only with the particles of this world, but perhaps with realities beyond. Time flows, at least that is how it appears. The clock ticks forward, never back. Memories gather in the past, possibilities unfold into the future. We are carried along a current that feels inescapable, irreversible. Yet, when we peer into the laws of physics, we find a strange truth. Most of them do not care about direction. The equations of quantum mechanics, of relativity, of electromagnetism, they work the same forward or backward. Why then do we feel time as an arrow? One answer lies in entropy, the measure of disorder. The second law of thermodynamics says that entropy tends to increase. A broken glass does not reassemble. Heat flows from hot to cold, not the other way around. This growth of disorder creates the arrow of time, but in the quantum world, the picture becomes more subtle. Entanglement, not entropy alone, may define the arrow of time. When two systems interact, they become entangled. Their states merge, their correlations increase. Entanglement grows, almost irreversibly. Just as entropy rises in classical physics, entanglement spreads in quantum physics. Systems become more linked, more correlated, more unified. This growth may be the true engine of time's arrow. The past is the state of less entanglement. The future is the state of more. As interactions accumulate, the world becomes more entangled, correlations weaving deeper into the fabric of reality. This view reshapes our understanding of memory and history. A memory is not merely a trace in the brain. It is an entangled correlation between brain and world, a link that records past interactions. The past is preserved because entanglement records it. The future is open because entanglement has yet to spread. In this sense, entanglement is the keeper of time. It preserves history. It drives evolution. It gives direction to becoming. Without entanglement, there would be no arrow, no flow, no unfolding. Some physicists suggest that entanglement entropy, the measure of how much two systems are correlated, may be the true definition of time. That time itself is not fundamental, but emergent, arising from the growth of entanglement. The ticking of clocks is not absolute, but a reflection of correlations deepening, states becoming more intertwined. If this is true, then time is not a river flowing independently of events. It is the spread of unity. It is the deepening of connection. It is the weaving of the world into wholeness. This vision is both scientific and poetic. It explains the arrow of time not as a brute fact, but as a consequence of entanglement. And it reminds us that time is not separation, but connection, the growth of unity across the cosmos. To reflect on this is to see time differently, not as a prison, not as a force, but as the unfolding of entanglement. The past is what is already woven. The future is what is yet to be entangled. And the present is the frontier, the moment of weaving, where unity grows. And perhaps when we feel time moving, what we truly feel is entanglement spreading, the invisible threads deepening, weaving us more tightly into the fabric of the universe. If entanglement shapes the arrow of time, a question arises. Can it also blur it? Can the future reach back into the past? At first, this seems impossible. Cause precedes effect. The past influences the future, not the other way around. This is the order we live by. Yet, quantum experiments suggest something stranger. In certain setups, delayed choice experiments, quantum erasers, the outcome of a measurement seems to depend on decisions made after the event. A photon passes through a beam splitter, yet whether it behaves as a wave or a particle appears to be determined by how we later choose to measure it. The future choice shapes the past behavior. How can this be? One explanation is that entanglement spans time as well as space. The correlations do not respect our ordinary sense of before and after. Instead, they link events into a single whole, beyond temporal order. In this view, the photon's past is not fixed until the measurement is made. Its history is entangled with the future choice. Past and future are not separate, but woven together in a timeless correlation. This does not mean that we can change history at will or send signals to the past. Entanglement preserves consistency. What it suggests is that our picture of time as a sequence of fixed past and open future is incomplete. At the quantum level, the boundary is blurred. The past is not fully determined until the entanglement is complete, until correlations span across time. Some physicists call this retrocausality. Others see it as evidence that time is not fundamental, but emergent. If space is woven from entanglement, perhaps time is too. Perhaps past and future are not separate realms, but perspectives on a single, entangled whole. Philosophically, this challenges our deepest intuitions. We think of ourselves as moving through time, leaving the past behind, entering the future. But entanglement suggests another picture, that past and future coexist, linked in unity. That the universe is not a sequence, but a tapestry, with correlations woven across time as well as space. To reflect on this is unsettling, yet also beautiful. It suggests that the past is not gone, that it remains entangled with the present, shaping it, linked to it. It suggests that the future, too, is already entangled, already connected, already part of the whole. In this vision, time is not a line but a web. Past, present, and future are not stages but threads, entangled in wholeness. And perhaps when you remember the past or imagine the future, you are not reaching across emptiness. You are touching the threads of entanglement that already link you across time. In this sense, retrocausality is not a violation of order, but a revelation of unity. It shows that time is not division, but connection, not sequence, but wholeness. That entanglement spans not only space, not only worlds, but time itself. And in that unity, the mystery of time softens. The past is not gone. The future is not distant. All are entangled. All are one. Life is delicate, complex, fragile. For centuries, scientists believed that biology could be explained in terms of classical physics. Molecules colliding, chemicals reacting, cells dividing. The messy warmth of living organisms seemed far removed from the delicate, fragile effects of quantum mechanics, which required isolation and control. Yet in recent decades, evidence has grown that life may depend on quantum effects, and perhaps even on entanglement. One of the first hints came from photosynthesis. In plants, algae, and bacteria, sunlight is captured and converted into energy. The process is astonishingly efficient, nearly perfect, with almost no energy wasted. For a long time, this efficiency was a mystery. Classical physics suggested that energy should be lost along the way, but experiments showed otherwise. The excitations created by light in photosynthetic complexes seem to travel through many paths simultaneously, exploring all possibilities at once, as if guided by quantum coherence. Even more surprising, some studies suggest that entanglement may help keep this coherence alive in the warm, noisy environment of a cell. Instead of destroying quantum effects, life may use its structure to protect and harness them. In this way, entanglement may underlie the very process that powers life on Earth. Another example lies in the eyes of birds. Migratory birds navigate across continents with uncanny accuracy, guided not by landmarks or stars alone, but by Earth's magnetic field. How do they sense it? One theory suggests that entangled particles in the bird's eyes, pairs of electrons created by light, act as tiny quantum compasses. Their entangled states are sensitive to magnetic fields, giving the bird a direct perception of Earth's invisible lines. If true, this means that entanglement guides the flights of birds across oceans, the migrations of life across seasons, the rhythms of nature itself, and there may be more. Some researchers propose that enzymes, the molecular machines that speed up chemical reactions in cells, use quantum tunneling, enhanced by entanglement, to make life's chemistry possible. Others explore whether the sense of smell depends on quantum effects, allowing noses to detect vibrations of molecules through entangled interactions. Though much of this remains debated, the pattern is clear. Life is not separate from the quantum world. It is immersed in it, perhaps even dependent on it. Entanglement may not only exist in laboratories, but in leaves, in wings, in senses, in the very processes that sustain us. If so, then the web of life is also a web of entanglement. Each cell is not only a chemical system, but a quantum one, with correlations linking particles in ways that classical physics cannot describe. Life itself may be entangled with its environment, sustained by invisible threads of correlation that tie it to the sun, to the earth, to the cosmos. Philosophically, this is profound. It means that life is not separate from the fundamental unity of the universe, that the same entanglement seen in photons also dances in leaves, flies in birds, beats in hearts, that living systems are not islands, but expressions of quantum wholeness. And perhaps when we walk in a forest or sit beneath the stars, we are not only surrounded by life, but immersed in entanglement. The rustle of leaves, the song of birds, the pulse of breath, all are part of the same unity, woven not only by ecology, but by quantum correlation. Life, in this sense, is the flowering of entanglement. It is the unfolding of unity into form, the weaving of correlation into complexity, the blossoming of wholeness into the beauty of living worlds. Among all the mysteries of life, none is deeper than consciousness. How does matter become aware? How do neurons give rise to experience? How does the brain, a network of cells and signals, create the unity of mind? Traditional neuroscience explains consciousness as an emergent property of classical processes, electrical signals, chemical exchanges, patterns of firing across billions of neurons. But some argue this picture is incomplete, for consciousness is not fragmented, but unified. The many sensations, thoughts, and memories are bound into one field of awareness. This unity echoes the unity of entanglement. Could entanglement play a role in consciousness? One proposal comes from the theory of orchestrated objective reduction, developed by Roger Penrose and Stuart Hameroff. They suggest that tiny structures in neurons, microtubules, may sustain quantum coherence and entanglement, allowing consciousness to arise not from classical patterns, but from quantum processes. Though controversial, the idea has sparked decades of research into the possibility of quantum mind. Others propose that entanglement could link distant parts of the brain, binding neural processes into a single whole. In this view, consciousness is not the firing of independent neurons, but the entanglement of their states, weaving unity from diversity. Even if such theories are unproven, the metaphor remains powerful. Consciousness is unity. Entanglement is unity. Both dissolve separation. Both reveal wholeness. Both transform many into one. Philosophically, this invites reflection. If consciousness arises from entanglement, then mind is not an isolated phenomenon, but part of the cosmic unity. It means that awareness itself is woven into the fabric of the universe, that thought and perception are not separate from physics, but expressions of its deepest truth. Even if consciousness does not literally depend on entanglement, the parallel enriches our understanding. It reminds us that the unity of experience mirrors the unity of the world, that the wholeness of mind reflects the wholeness of reality, and perhaps in moments of deep connection, with others, with nature, with the cosmos, what we feel is resonance with the underlying entanglement that binds all things. Perhaps the unity of consciousness is not only metaphor, but echo, not only resemblance but reflection of the unity at the heart of existence. In this sense, entanglement does not only shape physics, not only weave space, not only guide life, it may also illuminate the mystery of mind, the enigma of awareness, the wonder of being. And so, entanglement whispers again, nothing is separate. Not particles, not life, not mind. All are part of the same unity, woven by invisible threads into a single whole. When you step into a forest, it may appear as a collection of separate beings. Trees stand apart, each with its trunk and branches. Birds flutter overhead. Insects crawl across the bark. Streams run between roots. At first glance, the forest seems divided. Many organisms, many lives. But to look more closely is to see something else. A web of connection. A unity beneath the surface. The science of ecology has long shown that ecosystems are networks. Trees share nutrients through fungal networks beneath the soil, a subterranean web often called the Wood Wide Web. Predators regulate populations, which in turn shape vegetation, which in turn alters climate. Every being is linked directly or indirectly in a pattern of mutual influence. This ecological unity is more than metaphor. It is a physical reality. The breath of a tree becomes the air in your lungs. The carbon exhaled by your body feeds the leaves. The rain that nourishes roots evaporates to form clouds that drift across continents. To exist in an ecosystem is to exist in entanglement, not in the quantum sense alone, but in the sense of inseparable correlation. And yet perhaps the parallel with quantum entanglement runs deeper. Just as entanglement binds particles into wholeness, ecosystems bind lives into unity. Just as entanglement dissolves the idea of independent parts, ecology dissolves the idea of isolated organisms. In both, the truth is not separation, but relation. Consider the migration of monarch butterflies across North America. Generations are linked in a chain of journeys, each moving toward a destination they will never reach, but which their descendants will find. The flight is not the act of one butterfly alone, but of many generations entangled in time, weaving a single migration across centuries. Or think of coral reefs, where countless species form a single living structure, each dependent on the others, each woven into the whole. The reef is not one organism, nor many, but an entangled unity, a web of mutual being. In these systems, the metaphor of entanglement illuminates a truth, that life is not a collection of individuals, but a network of relations. That wholeness is more fundamental than parts. That unity is not abstract, but embodied in every breath, every interaction, every flow of energy and matter. Philosophically, this reshapes how we see ourselves. We are not separate beings walking through a world of others. We are entangled nodes in the web of life, sustained by connections, defined by relations. The food we eat, the air we breathe, the water we drink, all are entangled with the lives of others, with the cycles of Earth, with the unity of nature. And perhaps, just as quantum entanglement shows that the universe is one, ecological entanglement shows that life on Earth is one. That the forest is not many trees, but a single living unity. That humanity is not many individuals, but part of the biosphere, inseparable from its wholeness. To walk in nature with this awareness is to see differently. A tree is not only a tree, it is part of your breath. A bird is not only a bird, its migration is entangled with seasons, with climates, with continents. A stream is not only water, it is entangled with rain, with soil, with oceans. All are part of the same unity, visible and invisible, a tapestry of entanglement. And so ecosystems whisper the same truth as physics. Nothing is separate, everything is connected, wholeness is fundamental. If ecosystems reveal entanglement in nature, human societies reveal it in culture. At first glance, people may appear separate, individuals with their own bodies, their own thoughts, their own lives. But to look deeper is to see a web of connections, a fabric of relations, a unity that transcends individuality. Language is one thread. No word exists alone. Every sentence is an entanglement of meanings, shared across minds. To speak is to link yourself to others, to weave thought into the collective fabric. Economy is another. No one produces alone. The bread on your table is the result of countless entangled actions. Farmers growing wheat, millers grinding grain, bakers shaping dough, drivers transporting goods, workers building ovens, scientists inventing yeast strains. Every meal is an entangled unity of lives across the globe. Culture, too, is woven from entanglement. Stories are passed from generation to generation. Ideas spread across continents. Music blends traditions. Art reflects collective memory. What seems individual creation is always entangled with history, with society, with others. Even identity is entangled. Who you are is shaped by family, by community, by language, by culture, by history. The self is not isolated, but woven from countless threads of relation. To exist as a person is to exist in entanglement. This unity mirrors the wholeness of quantum entanglement. Just as particles cannot be described independently once entangled, people cannot be understood apart from their relations. The individual is not separate from society. Society is not separate from the individual. Both are aspects of a single, entangled whole. Technology amplifies this. In the digital age, information flows instantly across the globe. A thought in one place echoes in another. A discovery spreads worldwide in moments. We are more entangled than ever, not only through economics and culture, but through data, through communication, through networks that link billions into a single planetary web. This entanglement is double-edged. It creates unity, but also fragility. Just as entangled particles cannot be separated without loss, societies cannot fragment without harm. Disconnection leads to crisis. Ecological, cultural, political. Unity sustains, division destroys. Philosophically, this invites reflection. To live in society is to be part of an entangled whole. Your actions ripple outward, shaping others. Their actions ripple inward, shaping you. The boundary between self and other is porous, blurred, dissolved in the unity of relation. And perhaps, just as physics reveals that the universe is one entangled whole, sociology reveals that humanity is one entangled whole. That we are not many individuals, but one collective, woven by culture, language, economy, and shared destiny. To realize this is to see differently. Conflict is not separation, but entanglement, intention. Cooperation is not external, but intrinsic. Unity is not optional, but fundamental. In this sense, entanglement is not only a phenomenon of physics, but a metaphor of society. It shows that nothing exists alone, that wholeness is more real than parts, that our lives are threads in a fabric greater than ourselves. And perhaps in the silence of reflection, you may feel it, the invisible entanglement that links you to others, to community, to humanity, to the world. The unity beneath difference, the wholeness beneath division, the entanglement that sustains us all. Art has always been a mirror of connection. A painting, a sculpture, a poem, or a dance, none of these exist in isolation. Each is an entanglement of mind and matter, of artist and audience, of history and imagination. When you look at a painting, the pigments are not only colour on canvas, they are minerals drawn from the earth, ground by hands, brushed into form. They are centuries of technique, traditions passed from one artist to another, whispers of culture layered into each stroke. When you stand before the work, you are not separate. Your gaze completes it. Your perception entangles with the image, weaving meaning that is unique to you, yet connected to the artist's intent. Art is, in this sense, an entangled system. The artist creates, the viewer perceives, and between them arises something neither could make alone. Meaning exists not in the object nor in the mind, but in the relation, in the invisible thread of interpretation. This mirrors quantum entanglement. Just as particles are not defined until observed in relation, art is not complete until engaged with. The painting without a viewer is potential. With a viewer, it becomes actualized meaning. The artwork, like the wave function, unfolds in the entanglement of observer and observed. Consider literature. A novel is not merely ink on a page. It is a network of symbols, entangled with language, culture, and imagination. When you read, your mind entangles with the text, bringing characters to life, shaping landscapes, hearing voices. The story is not simply written, it is co-created in the entanglement of words and reader. Or think of architecture. A building is not only stone and steel, it is history entangled with purpose, geometry entangled with culture, space entangled with lives. The cathedral is not only an edifice, but a vessel of centuries, entangled with prayers, with rituals, with memories. To walk through it is to step into a field of entanglement, where matter and meaning are inseparable. Even abstract art, seemingly distant from representation, is an entangled dialogue. A splash of colour, a shape, a rhythm, each entangles with perception, with thought, with feeling. Meaning arises not from the canvas alone, nor from the mind alone, but from their unity. Philosophically, this shows that art is not an isolated creation. It is entangled with the world, with culture, with time, with the lives of others. It reminds us that beauty is not separate, but relational. That expression is not solitary, but woven. And perhaps this is why art moves us so deeply. It reflects the truth of entanglement. It dissolves boundaries between self and other, between creator and perceiver, between matter and meaning. It reveals wholeness, not as abstraction, but as lived experience. In this sense, every artwork is an echo of entanglement. It shows that reality is not fragments, but relations, not separations but unities, not objects but connections. And so when you look at a painting, read a poem, enter a building, or witness a dance, remember, you are not an observer apart. You are part of the entangled whole, woven into the artwork, woven into its meaning, woven into the unity it reveals. If art reveals entanglement through form and image, music reveals it through vibration and time. Music is, at its essence, relation. A single note may exist, but it is in harmony, in rhythm, in resonance with others that music arises. Sound is not only frequency, but connection. Consider a chord. 3 notes played together create something more than the sum of parts. Their frequencies interfere, resonate, entangle into harmony. The sound is not in one note, nor another, but in the relation between them. This is entanglement expressed as sound, or think of rhythm. A beat is not only a strike of a drum, it is the relation between beats, the spacing, the intervals, the silence in between. Rhythm arises from entangled timing, from correlation across moments. Melody, too, is entanglement. A sequence of notes gains meaning not from each alone, but from their relation, their unfolding, their memory. The first note entangles with the second with the third, the whole forming a pattern that carries emotion, memory, and story. And when musicians play together, the entanglement deepens. A symphony is not one violin, one flute, one drum. It is their unity, their resonance, their coherence. Each player listens, adjusts, responds. The music is not in individuals, but in the whole, woven from countless entangled actions. This mirrors quantum entanglement profoundly. Just as particles lose individual identity when entangled, notes lose separateness when woven into harmony. Just as entanglement creates unity beyond parts, music creates beauty beyond notes. Both reveal that relation is more fundamental than isolation. Even in silence, music reflects entanglement. The pause between notes is not absence but relation, shaping meaning, defining rhythm. Silence is entangled with sound, presence with absence, creating wholeness. Philosophically, music teaches that beauty is not in things, but in relations. That harmony arises from unity, not division. That resonance is the essence of being. On a human level, music is also social entanglement. A song sung together binds voices, hearts, and minds. A rhythm danced unites bodies in movement. A melody shared across generations entangles lives across time. Music is not only sound, but connection, weaving individuals into community, culture, humanity. Think of a lullaby, whispered by a parent to a child. The melody is not only notes, it is love entangled with sound, comfort entangled with vibration, memory entangled with moment. Or think of a festival, where thousands move to the same rhythm. The music is not only performance, it is entanglement in motion, unity embodied. And perhaps this is why music moves us so deeply. It resonates with the entanglement at the heart of reality. It dissolves boundaries between self and other, between sound and silence, between matter and meaning. It reflects the wholeness of the cosmos, made audible. In this sense, every song is a whisper of entanglement, every harmony is a glimpse of unity, every rhythm is an echo of the invisible threads that bind all things. To listen to music is to enter entanglement, to feel unity, to be reminded that the world is not fragments, but resonance, not isolation, but connection, not chaos, but harmony. And perhaps when you are moved by a melody, when your body sways to rhythm, when your heart resonates with song, you are not only hearing sound, you are hearing entanglement itself, made audible, made beautiful, made human. Long before physicists split photons or traced the mathematics of quantum mechanics, human beings intuited a truth: nothing exists alone. Across cultures, across centuries, myths and symbols emerged that spoke of invisible threads, hidden connections, secret unities beneath the world of appearances. In the ancient Vedic tradition of India, there is the concept of Indra's net. Imagine an infinite web stretching across the cosmos, each intersection holding a jewel. Each jewel reflects every other, endlessly, so that the whole universe is mirrored within each point. Nothing exists in isolation. Each part contains the whole. This is a metaphor of entanglement, centuries before the language of quantum theory. In Taoism, the Tao is the way, the underlying unity from which all opposites arise. Yin and yang are not separate but entangled, each containing the seed of the other, each defined by relation, not isolation. The balance of opposites reflects the truth that wholeness transcends division. In Native American traditions, the web of life is a central image. The Lakota speak of mitakuye o yasing, all my relations, a recognition that all beings, human and non-human, are kin, entangled in unity. The spider's web is often a symbol of this truth, threads linking all things, visible and invisible. Even in Western traditions, echoes of entanglement appear. In Greek mythology, the Moirai, the fates, weave the threads of life, each destiny bound to others, each life entangled in the tapestry of existence. In Norse mythology, the world tree, Yggdrasil, connects realms, its roots and branches, weaving worlds into unity. These myths are not physics, but they speak a symbolic truth that mirrors entanglement, that reality is not fragments, but relations, not separations, but wholeness, not chaos, but unity. Symbols also reveal this. The circle, found in mandalas, in halos, in wheels of time, is a symbol of wholeness, of connection without beginning or end. The spiral, found in shells, galaxies, and sacred art, reflects unity unfolding, entanglement expanding. The knot, Celtic knots, endless loops, woven patterns, represents inseparability, threads entwined beyond separation. Why do such images appear across cultures? Perhaps because human beings have always sensed entanglement, not in equations, but in experience. The bond between parent and child, the unity of community, the resonance of nature, these are lived entanglements. Myths and symbols give them form, echoing the invisible truth of connection. Philosophically, this shows that entanglement is not only scientific discovery, but human intuition. That long before quantum mechanics, people understood that wholeness is deeper than division, that invisible threads bind all things. And perhaps when we hear ancient myths, when we see timeless symbols, we are hearing the human imagination resonate with the truth of entanglement. We are hearing echoes of a unity that physics now confirms, a wholeness that culture has always known. In this sense, myth and symbol are not separate from science, but parallel expressions of the same truth. Nothing exists alone. Everything is entangled. Wholeness is the foundation of reality. If myth and symbol express entanglement in story and image, spirituality expresses it in practice and experience. Across traditions, across paths, seekers have spoken of unity, of oneness, of dissolution, of separation. These are not descriptions of quantum mechanics, but they resonate with the same truth. That reality is not fragments, but whole. In Buddhism, the doctrine of pratitya samutpada, dependent origination, teaches that nothing exists independently. All phenomena arise in relation, in interdependence. The self is not separate, but entangled with conditions, causes, and others. To awaken is to see this truth directly, to dissolve the illusion of separateness. In Hindu philosophy, the Upanishads speak of Brahman, the ultimate reality, the unity underlying all. The individual self, Atman, is not separate but identical with Brahman. To realize this is liberation, to know that all is one, that separateness is illusion, that wholeness is the truth. In Christian mysticism, there is the idea of union with God, of dissolving the boundary between self and divine, of entering into wholeness beyond separation. In Sufi mysticism, the seeker longs for annihilation of self in the beloved, for entanglement with the divine, for unity beyond individuality. Indigenous traditions around the world speak of spirits inhabiting rivers, mountains, animals, weaving humans into a sacred web. To harm the earth is to harm oneself, for all are entangled in one life. These spiritual insights echo the language of entanglement. Nothing is separate, all is connected, unity is deeper than division. They are not physics, but they are parallel ways of knowing. Even practices reflect this. Meditation dissolves the boundary of self, revealing awareness as interconnected, entangled with all. Prayer links the individual to community, to tradition, to the divine. Ritual binds participants into unity, weaving individuals into collective meaning. Philosophically, spirituality shows that entanglement is not only a phenomenon of matter, but an experience of being. That wholeness is not only scientific truth, but lived truth, accessible in silence, in devotion, in awareness. And perhaps this is why entanglement resonates so deeply. It is not only an experiment in physics, not only a mathematical equation, but an echo of something humans have always known. That we are not separate, that unity is the essence of existence, that wholeness is the ground of being. To see entanglement as spiritual is not to confuse physics with religion, but to recognize resonance. Both reveal wholeness, both dissolve separation, both point beyond the fragmentary view of reality to the unity beneath. And perhaps in quiet moments, when you feel connected to others, to nature, to the cosmos, you are experiencing entanglement in another language. Perhaps spirituality is the human way of living the truth that physics describes, that nothing exists alone, that all is bound, that wholeness is the essence of reality. In this sense, entanglement bridges science and spirit. It shows that the unity sought in equations and the unity sought in meditation are not opposed but parallel, reflections of the same truth. And so, entanglement is not only a phenomenon of particles, but a symbol of meaning, a guide to wholeness, a reminder that we are already connected, already whole, already part of the unity that is. Death is perhaps the greatest boundary we know. It marks the end of breath, the silence after heartbeat, the dissolving of individuality. For as long as humans have lived, they have stood before this mystery with awe, with fear, with reverence. Yet when viewed through the lens of entanglement, death may not be absolute separation, but transformation. For if nothing exists alone, then perhaps even death does not sever the threads, but reweaves them. In the physical sense, this is clear. The body does not vanish, it transforms. Molecules return to earth, atoms to air, energy to cycles of life. The carbon in your breath becomes part of leaves. The minerals in your bones part of soil. The warmth of your body dissipates into the environment. Death in this sense is not an end, but entanglement returning, the rejoining of matter and energy to the whole. But what of the less tangible, the self, the consciousness, the memory? Here too, entanglement offers a lens, for the self is not isolated, but relational. Your identity is woven from connections, with family, with friends, with community. Even when the body ceases, these threads endure. Memories ripple outward, actions shape futures. Love continues in those who remain. Death does not end entanglement, it transforms its form. In physics, entanglement itself cannot be destroyed. It may change, spread, degrade, but correlation is preserved. This suggests a metaphor, that the entanglement of a life, the connections, the relations, the unity with others, is never erased. It continues in echoes, in ripples, in transformations. Cultural traditions reflect this truth. Ancestor veneration honours the continuing presence of the dead in the lives of the living. Rituals of remembrance keep connections alive. Stories preserve the threads of lives across generations. In this way, death is not absence, but a shift in entanglement, from presence to memory, from physicality to legacy. Philosophically, this challenges our view of death as separation. It suggests that the self is not an isolated entity that ends, but a node in a web of entanglement that continues. To die is not to vanish, but to dissolve into wholeness, to become part of the unity that is. Even the fear of death may be softened in this light, for what we fear is separation, the end of connection, the loss of self. But if entanglement is truth, then there is no absolute separation. The threads continue, the unity remains, the whole endures. In this sense, death is not rupture, but return. It is the loosening of individual entanglement into universal entanglement, the release of separateness into wholeness. And perhaps in quiet reflection, we can feel this. When you sit with memory, when you honour the presence of those gone, when you sense continuity across generations, you feel entanglement beyond death. The threads are not broken, the unity is not lost, the wholeness remains. If death is transformation, then legacy is continuity. It is the way entanglement extends beyond a single life, weaving threads into the future, binding generations into wholeness. Every action is entangled. The kindness you give ripples outward, shaping others in ways unseen. The words you speak may echo in memory, may inspire, may guide. The work you do may build foundations for others to stand upon. Each act, however small, entangles with the world, leaving traces that endure. This is not metaphor alone. Consider ecology. The tree that falls in a forest decays into soil, feeding new life. The nutrients entangle into roots, into leaves, into future forests. The life of one becomes entangled in the life of many. Or consider culture. A story told becomes memory in another. A song sung becomes melody in another voice. A discovery made becomes knowledge for others to build upon. Human culture is entanglement across time, each generation weaving into the next. Even in physics, legacy is entanglement. The light of stars long dead still reaches us. Photons entangled with their birth billions of years ago, carrying their memory across cosmic time. In the night sky, we see not only present stars, but the legacies of vanished ones, their light still entangled with our gaze. Philosophically, legacy shows that life is not bounded by birth and death. It extends in threads of entanglement, weaving into future lives, shaping futures unseen. To live is to entangle, to leave traces, to continue beyond oneself. This truth can transform how we live. If every action is entangled, then none is insignificant. Every kindness ripples outward, every cruelty too. Every choice is a thread in the web of legacy, shaping the wholeness of the future. It also softens the fear of mortality. For while the self may pass, the entanglements remain. The love given, the work done, the presence shared, these continue, woven into the lives of others, into the fabric of the world. Death does not erase entanglement, it spreads it. And perhaps to live well is to entangle well, to weave threads of care, of beauty, of meaning into the web of life. To recognize that we are not isolated, but part of a unity, that our lives are not solitary, but woven into wholeness. In this way, legacy is not grandeur or fame, but entanglement. It is the invisible threads we leave, the unity we weave, the wholeness we sustain. And so, entanglement whispers again. Nothing is lost, nothing is separate, everything continues in wholeness. Life, death, legacy, all are threads in the same web, woven beyond time, beyond self, into the unity of the cosmos. Step back for a moment, not from a laboratory experiment, not from a forest, not from a community, but from the entire cosmos itself. Imagine the universe not as scattered stars in empty space, but as a single tapestry, vast beyond measure, woven of matter, energy, space, and time. In this view, entanglement is not a minor detail, not a curiosity of physics, but the very thread of the tapestry. For if particles are not separate, then stars are not separate, galaxies are not separate, beings are not separate. All are entangled, all are connected, all are woven into unity. Look at the night sky. Each star is light years away, yet the photons that enter your eyes are entangled with their origins, carrying information, carrying memory. The galaxies spinning in silence are not isolated islands, but parts of a cosmic web, connected by gravity, by light, by quantum threads. Cosmology tells us the universe began in a single moment, a singularity expanding into space and time. From that moment, all particles, all forces, all structures emerge together. In a profound sense, everything remains entangled with that beginning. Every atom in your body was born in that explosion. Every particle shares its origin with every other. We are not separate fragments, but expressions of one birth, one unfolding, one unity. Even across cosmic distances, entanglement persists. Quantum experiments show that correlation does not diminish with space, that particles entangled remain linked across vast separations. This suggests that the unity of the cosmos is not limited by distance, that wholeness transcends space. Philosophically, this reshapes how we see the universe. It is not a machine of separate parts, but a living web, not fragmentation, but wholeness, not isolation, but entanglement. Consider the cosmic microwave background, the faint radiation left from the early universe. It fills all space, a whisper of the origin, entangled across billions of years. When we detect it, we are not only observing the past, we are entangled with it, linked across time. Or consider black holes. When matter falls into them, entanglement is not lost, but transformed. The paradoxes of physics here, information seemingly vanishing, entanglement stretching, remind us that wholeness is deeper than our current understanding, that even at the edge of knowledge, unity remains. In this sense, the cosmos itself is an entangled whole. From the smallest particles to the largest structures, from the birth of stars to the birth of thought, all is woven together. The universe is not many, but one, and to feel this is to change perspective. The self is not isolated, the world not alien, the cosmos not distant. All is part of one tapestry, one web, one unity. To live is to be a thread in this vast entanglement, shimmering with the same light as galaxies, woven into the same fabric as stars. This vision is not abstraction, it is lived. When you gaze at the sky, when you feel awe, when you sense belonging, you are touching this truth. You are feeling entanglement, not in equations, but in being. And perhaps, when humanity looks outward, beyond Earth, beyond solar system, beyond galaxy, what we will find is not separation, but wholeness. That the cosmos is not alien, but home. That we are not visitors, but threads in the cosmic tapestry. That entanglement is not phenomenon, but reality itself. Now we come to the end, not the end of entanglement, for that has no end, but the end of this journey of reflection. We have traced entanglement from particles to people, from life to mind, from art to spirit, from death to cosmos. At every step, the message has been the same. Nothing exists alone. Separation is illusion. Wholeness is truth. Entanglement shows us that the universe is not fragments, but unity. That particles are not independent, but correlations. That life is not isolated, but interwoven. That mind is not solitary, but connected. That society, culture, art, and spirit all reflect the same truth. We are not separate. We are entangled. What does this mean for us? It means that the boundary between self and other is not absolute. That every action ripples outward, shaping the whole. That care for others is care for self, for the web is one. That harm to others is harm to self, for the web is inseparable. It means that awe, love, compassion are not abstractions, but reflections of reality. They arise when we feel entanglement, when we recognize unity, when we live wholeness. It means that science and spirit are not opposed, but parallel paths to the same truth. One describes entanglement with equations, the other with experience. Both dissolve division, both reveal wholeness, both point to unity beyond words. It means that death is not end, but transformation. That legacy is not illusion, but continuity. That life is not solitary, but part of a cosmic unfolding. And it means that the universe itself is not alien, not hostile, not indifferent. It is home, it is wholeness, it is entanglement. Perhaps this is the final whisper of entanglement, that we are already what we seek, already whole, already connected, already one with the cosmos. The journey is not to create unity, but to remember it. Not to build wholeness, but to awaken to it. In the end, entanglement is not merely physics, not merely philosophy, not merely metaphor. It is reality. It is the truth that nothing is separate, that everything is one, that wholeness is the essence of existence. And so, as this reflection closes, let the final words be simple. You are not alone. You are entangled. You are part of the whole. You are the cosmos, woven into unity, shimmering with the light of stars. The whisper of entanglement is the whisper of being itself. Nothing is separate. All is one. Wholeness is reality.